Okay friends, this is the third video. In previous two videos we discussed about the electric field, electric force and the energy because of the discrete charge distribution. Now we are slightly going to modify the problem. Now we want to look the electric field or the electrostatic force at the point charge Q located at this location because of the other uh, different type of charge contribution. We are interested in the electric field at that point because of this charge Q, which is a point charge, and the line charge, this lambda. So we have two type of combination here, like this one is the discrete and this one is of continuous charge distribution in this line. So we want to find the electric field at this point. As usual, we use the superposition principle to calculate the net electric field, which is the electric field at that point Q because of the charge Q, and the electric field at that point because of the continuous charge distribution along the x-axis up to length L because of this the length charge lambda. So this gives me the total electric field at that point. And uh, uh, yeah and to calculate the force to calculate the force we can use just the similarly the force net also equals to the force because of the q charge plus force because of the lambda charge distribution. So as we know, uh, in electrostatics, if we have a charge q in the electric field E, then the force experienced by this charge in the electric field is charge into the electric field, right? So what we do here is first we calculate the electric field because of this line charge distribution at this point. Then after we calculate the force when the q charge is placed on that field created by this line. This is the simple procedure we have to move with, right? So let's begin with the problem. Okay, so this is my line charge. Let me consider a small, and this is my line charge, and this is the point charge q where I'm interested to find the electric field and the electric force experienced by this q charge. Let's write its the location. The location of the charge q is, as we can see from here, this is L and this is L. So the charge location is 2L and L. So 2L, L and G is 0. So it is on the XY plane. So its coordinate in XY plane I can write as 2L and L. This is L and this is L. This up to here is L and here to here is L. Okay, so now I'm going to consider this small line charge of length dx lies at a distance x from the origin. This distance is x, this distance is x, lies x distance away from the origin. Then the charge carried by that small element is its length into lambda. This is the charge carried by that small length element, and the position vector of that small length element is r lambda is x along y-axis. Okay, position vector of q is 2li plus lg, and and we have next charge here that we need to consider. The magnitude of the charge is given as q at a distance l above it is the charge q above the distance L. So the position vector of Q is equal to the LG. So these are the three important things we should consider. Then we write when we are interested in the force on the charge Q, net force on the charge Q, which is equal to the force on the charge Q because of Q, small q, plus force on the charge Q because of the lambda charge distribution. But we have already done this type of problem, how to calculate the force because of this small discrete charge, already in our previous sets. As we know, f of q could be written as k uh, q into q upon the distance square. Distance square is the distance square, or we could write r q minus rq divided by rq minus rq. This actually, why I'm following this the lengthy technique, you don't feel this is the lengthy and the boring technique, because it is the secure technique to find the perfect answer with all the specified direction. You don't have to worry about the directions and other things when you follow this proper procedures. Otherwise directly you can write k q1 q2 by 2l square, that is also fine, but the direction could be sometimes confusing, so it is good for you to follow the proper procedure. So I am following this proper rule. Now I calculate to do this, I calculate rq minus rq equals to rq minus rq equals to 2li, and its modulus is rq minus rq modulus is equal to the 4l square. So I can write fq as force because of charge, q as kqq into 2l into I vector divided by this whole cube is, okay, root under 4l 2l, this is 8l cube, 8l cube. We can cancel out this as 4 kqq by 4l square. And as I said, you don't think why I am doing on this lengthy way and the boring way. I am doing this because this is the most fundamental technique to calculate this, so that there will be no any possibility of having done wrong way. So this is my the electric force experienced by the charge q because of this small charge q. Now I calculate the electric force, this part of that equation a, this is 2, this is 1. In equation a, I found this one. Now I need to calculate the force because of force exerted on the charge q because of that continuous charge distribution on the length L along the x-axis. As I explained before, the technique is, first we calculate the electric field at that point because of this whole length charge distribution. Then I use the formula F equal to Q into electric field, right? So first I need to calculate electric field at that point because of the charge distribution. So calculation of electric field, calculation of electric field at Q, calculation of electric field at Q. I have supposed here a point charge. You can sorry, the small charge element which has charge this. First I calculate the electric field because of this small charge which is at that distance. So as you know, the electric field formula of the electric field is charge is the dq k dq over by r lambda this is the, yes, uh, the position vector of the dq element r lambda, sorry, mm, is r cube. Why this is not okay? This r cube minus r lambda cube, r cube minus r lambda. All right, so let's calculate that vector, r cube vector minus r lambda vector equals to this minus this, so 2l minus x I plus l z, and their modulus is r cube minus r lambda modulus is root under 2l minus x square plus l square. So I can write electric field as k dq 2l minus x I plus lz over by 2l minus x square plus l square to the power 3 by 2. This is because of the small element dl, the dx. Now in order to calculate the total, I need to integrate the whole length. If you look on the figure now the d is the field because of this small element. Now if I want the electric field, total electric field, because of this whole continuous charge distribution in the length, I have to integrate the length of the charge distribution from L equal to 0 to L equals to, sorry, the x equal to L, x equal to 0 to x equal to L. I'm gonna do that. Let me say this is d, this is d, then E, because of the whole charge distribution, is integrating from x equal to 0 to L over dE, which is equal to k dq. dq is what? Dq, I have not replaced that. Dq is lambda into dx. So lambda is the constant. I can take that out of the integration sign. So I can write lambda k 0 to infinite dx 2l minus x over by 2l minus x square plus l square 3 by 2 equals to k lambda. If you do this integration, you will get 1 by root under 5l square minus 4lx plus x square. Integration is pretty simple. You can do in rough. You can pause video and do in rough. I'm just skipping that mathematics part. And if you replace this x by l and uh, proceed on the small algebra, finally you will come up with 1 by root under 2 minus 1 by root under 5. This is the electric field because of the x component of the uh, x component of the x component of the electric field at that point, because you can see here, maybe I forgot to explain that thing here. We have two component, x component and j component. Here I am taking, you can see here I'm taking only the x component, this part x component, which is along I axis, right? I'm taking only x component. Now I do similarly for the j component. This is for I component, x component. Similarly for g component, sorry, the y component, I integrate over the same branes. I will have 0 to L into, I forgot here to write x, dy, which is equal to this part, L by this part, KL by that part. So my KL would be common, 0 to L, and dy divided by the dx divided by, we didn't have dy, dx L into dx. This is the lambda into dx. Lambda is common, L and lambda are common, lambda is also common, sorry, I forgot to write, lambda is common. Then dx over by 2l minus x, 2l minus x square plus l square to power 3 by 2 equal to k lambda l, uh, 2l minus x minus 2l minus x divided by l square root under 5x square minus 4lx plus x square, and integration over 0 to L, right? If you do small algebra, here also you would finally get k lambda by L minus 1 by 2 plus 2 by root under 5 along z direction. So my E total becomes mm, so my E total becomes E total because of the lambda, let's say E total because of the lambda becomes E lambda of x plus E lambda of y, right? So E lambda of x and E lambda of y we get, if you look on here, E lambda by x is 1 by root 2 minus 1 by root 5, minus 1 by root 5 I plus uh, minus 1 by 2 when I keep L equal to 0, uh, L is square, this is L, this is root under 2, maybe I did some mistake, minus L by root under 2 plus 2 by plus 2 by root under 5. Okay, this is my total electric field. If we go up, you can look here, how do I calculate electric the force on the charge because of the electric field is Q into that electric field. I have charge here, I have line charge here, it gives some electric field at that point, and that electric field pushes the charge, so we need to calculate that contribution of the electric field on the total force. So the electric force on Q because of lambda is Q into electric field at lambda equals to k lambda Q by L into 1 by root 2 minus 2 by root 5, 1 by root 5 I plus minus 1 by root 2 plus 2 by root 5 G J. Okay, this is the force. Now the total force is because of, now the total force, this is the force, this is expression 2. Expression 2 is the force because of the line charge lambda, and this is the force because of the charge Q. So Q also gives some forces, this also gives some forces. So in order to calculate the total net force on the Q, we need to calculate the net force by using the superposition principle. Let's go ahead and let me mark this expression as this expression as the, let me copy this and let me go down here. F total is now F net is F net on Q is equals to F due to Q plus F due to lambda equals to F due to lambda is this, right? F due to lambda is this. Along I direction, and this plus L. Okay, let me copy this. Better I would copy. Okay, I'm not that straight. Copy. Let me copy it here. Okay, this part. And this part would give me the, so this is the expression of my total force. So I can add these two x components at a place. If you add these components at a place, this x component at some place, you would get something. Instead of this, you will get kq by 4l square plus k lambda cube by l 1 by root 2 minus 1 by root under 5 I plus k lambda cube by l. This is the along z direction. This is the total force, or let's say the net force experienced by the, actually don't be confused by this line, it is just the, I'm just incorporating these two in one line. Okay, so this is the total net force on the charge q because of the two charges. One is point charge and next one is the line charge along the x-axis. Okay, see you in the next video.